Hola! Hola, ¿qué tal? So yeah, the this session was well scheduled for this moment. It was like exceptional. Just because Kevin was not available just before, but that's okay. Normally, you will receive the calendar invitation with this hour. Normally. Hi, Kevin.
Hey, what's going on? How are you?
I'm great. I'm great. Um, and you
Doing good. Yeah, I'm just trying to fix my camera here. There we go.
come back home.
Make sure I got the right
All right.
AirPods. Can you guys hear me okay? Yeah?
Yeah, sure, sure, sure. All good.
Amazing. Cool.
Yes, because people actually showing up 1 hour before, and and yeah, I explained the session is exceptionally at this time. So yeah.
Yeah, sorry everybody. I had another meeting I couldn't move around, so I appreciate you guys being flexible. So thank you.
Of course.
Cool. We want to give people some time to hop in. Yep.
Yeah, yeah, yeah. Because it's like 7, so at least having 2 minutes where people come will be great. And so I will just share my screen a bit. Oh, alors, tux. Where is that? No, not that. So, just back. Uh, Discovery basket. Yeah, this one. So I will just share my screen a few seconds. Yeah. So actually, don't forget you can find all information because I saw a couple of questions on our Telegram group related to where I can find like the recording and everything. So first of all, every night, I mean after each session, we are sending an email with all information, especially like a recap. Um, and then we also updating this notion on a daily basis. So you can find here, for example, the content that has been like showcased during the session, and also the recording link. So no worries about that. Really, everything just goes through Notion. You can find that. And yesterday, Kevin talked about this Notion. So on this Notion, its whole um, is actually he's everything explaining. So you can go through it and find all of that. And also another thing is about the speedrun challenges. So, for example, today someone DM me and said, "I don't understand why people send some like address on Telegram. It's just because they need funds, they need Sepolia Hits. So I send to them Sepolia Hits in order to complete these challenges. So today we're gonna talk about that. In addition, so I don't know if you want Kevin to start with it, because I mean, like actually I don't know, 32 people. Yes, probably let's say at the end, like are when everyone will be there, I guess. And then at the end, when you have completed the challenge, don't forget to just fill in this form to say, okay, I completed, there is my profile. Because I'm checking on my side if everything is okay and all good. That's fine. So you have to complete this challenge in order to be officially accepted into the fellowship. It's like just a motivation challenge. It's really chill. No reason. If you are stuck somewhere, don't hesitate to ask any help. Like I mean, we are pretty reactive, pretty responsive. So everything is okay. And I will check, like making a individual check too, from, I guess, Friday. Because tomorrow is my birthday, so I will be kinda like out of office. And so probably someone else will replace me tomorrow in order to record the session, because I will be potentially into the car. So it's gonna be quite challenging to run the session in the car. All good?
Happy early birthday.
Thank you, by the way. All
Nice.
good.
Okay.
Thank you.
So was the ask that we do the normal session, but then also go through the challenge zero for people so they know how to do
Yeah.
it? Is that kind of, yeah?
Yeah,
Okay,
exactly.
cool. Yeah, no problem. Let's try to squeeze it in. I'll use that as my like last kind of section. We'll do that. Cool. Are we ready to go?
Yes, all good.
Awesome. Cool. All right. Thank you so much, everybody, again for being here today. Really excited to see you guys for a second day. Today, we're going to be focusing on particularly the EVM. So EVM stands for Ethereum Virtual Machine, and we're going to be talking a little bit more about that. We're going to be talking about like actually Solidity, which is the programming language, well, the most popular programming language for writing smart contracts. And we're going to take a look at some of the syntax so you can kind of get a feel for it. And then we'll leave some time to actually build the first challenge of the NFT challenge for Speedrun Ethereum. So we'll walk through it. I'll create a new account and we'll just go ahead and try to do it. So, all right, cool. Let's get started. So let me go ahead and share my screen. And let's go. All right, cool. So you guys have the notion. We're going to be focusing on this section. By the way, there's this whole section about the graph and data indexing that we won't cover, but there's some good information in there. I would recommend going through it at some point. But today we're going to be focusing on this part. And we're going to be talking about what the Ethereum virtual machine is and kind of just like very high level technical how it works, because it's really good to understand exactly like how Ethereum actually works under the hood, especially when you're a developer, because you kind of have these little concepts that you're not used to from like traditional Web 2. And so again, there's a recorded session of this that I did before, and then there's the session that you're going to get, which is a replay of this. So go ahead and watch that. But first, let's just talk about like what the EVM is. So it's a virtual machine. So just like you would run a virtual machine on your computer, if you wanted to run like Linux on your Windows machine or whatever, it's basically like a virtual operating system or confined environment that runs a specific set of instructions in a certain way. So just like you run Linux on Windows with WSL, or you might run Linux on your MacBook as a virtual machine. Every single node on the Ethereum blockchain, and when I say node, those are like participants that are running the Ethereum blockchain on their computer or their server, is running a copy of the EVM. So the idea for the EVM is that all of these nodes are acting as one giant computer. So if you have 1,000 different people running a copy of the Ethereum virtual machine on their computer, and they're all connected in a network that is sharing their data, that is acting as one single unit. So the EVM is this one single machine, and it uses cryptography to talk into it and to talk out of it. So the only way that you can send any data into the virtual machine is with cryptography, with signing, transactions. And anything that happens inside is isolated, and it only works based off of the instructions it has coming through the smart contract. Okay. So if we look at this and we say, okay, well, what is it really? So it's three parts. It's the state, which we talked about it yesterday, where you like have variables and they change from like Boolean changes from true to false, a one changes to a two, a string changes from hello to goodbye. It's the state of the machine. And that is all handled with these instructions. And then there's the virtual memory, which is stuff that just happens inside that's immutable. Basically, it's stuff that cannot be changed, right? This is stuff that's inside of the EVM code that maybe are like immutable variables. Like let's say you always want a variable to stay the same. you can define it as immutable and it can never be altered, which is really powerful because you don't want someone to be able to just change a one to a two or a three to a four at any time. You can create this like immutable virtual like thing inside of the code. And then there's this world state, which is world state is similar to the machine state, but it's more about the accounts. Okay. So in Ethereum, you have this concept of accounts. Your account that you generate with your private key and your public key, your wallet, is an account. And in order to keep track of its balance on how much ETH it has to have its own state. Same thing goes for smart contracts. When you deploy a smart contract, you deploy it and an account is created for that smart contract. And so there's smart accounts and then there's EOA accounts. Smart accounts are basically contracts, and accounts that are like EOAs, they're called externally owned accounts. That's like a wallet. Like if you have a wallet on your phone and someone sends you some ETH, it gets put into this account storage. Okay. So this is immutable data that gets executed inside of the smart contract. This is information that is keeping track of like balances mostly for different accounts, whether it's your wallet or a smart account like a smart contract. And then this is the stuff that is the processing inside of the virtual machine. So this is kind of like the workhorse that when you send a transaction to the Ethereum virtual machine and it gets picked up and processed, it has to go through these four things. So it has to, first of all, there's a counter. So because when in blockchain, we deal in this concept of nonces, and I'll just talk briefly about it. You don't need to get too technical, but the idea is that there's a certain number of transactions that have to happen in a certain order. So things get processed first, second, third, fourth, fifth, sixth, and so on in a block. So if you have a wallet that sends a transaction, it also passes a nonce. And this is just to keep this concept of like double spending, right? We only want a wallet to be able to submit one particular transaction, and then he has to wait until that program, his nonce changes to submit a second one. I'm getting a little bit in the weeds, but I'm just want you to understand that there's this counter that happens. And then there's a memory architecture as well, where it's called a stack-based memory architecture. I'll talk about that in a little bit. And then we already talked about gas, is you have to pay some gas to change the state of the smart contract or whatever. And then there's this memory as well. There's like internal memory. So this is kind of what it looks like. I see that there's maybe a question. Let's see. What does ROM stand for? Read-only memory. So it means that it can't be written to. So read-only memory is like this concept of just read-only, and that's immutable things. So when you deploy a smart contract to Ethereum, it lives forever as immutable code. You technically can never change it. You can try to delete it, but when you deploy a smart contract, it lives forever. And so that is an immutable thing. And you can also define variables as immutable as well. So relating this to COA, I'm not sure about computer organization and architecture. I'm not sure. Okay, so let's keep going. So then we have this concept of like, here's what a transaction looks like. We talked a little bit about it yesterday, but with Ethereum, you send in gas with your transaction. So just like you pay Amazon to like host your web server, but in this case, you pay every time you make an update. So imagine if you were doing an HTTP call or an API call, and every time you had to send some money in the API call. That's kind of what you're doing. You're sending in this gas. The gas is money. It has a value. It's called Wei. It's the lowest denomination of Ether. And Ether is what powers the blockchain. And you also have a counter. So you say, okay, well, this is my first transaction. So my nonce is 0. And I want to execute this code on the blockchain. These operations happen, which are what we call opcodes, but basically the code gets compiled down into assembly, and those assembly are executed. So this part is a little abstracted for you during all of this stuff. You're not going to learn a lot about assembly and opcodes, but you can just imagine that you're basically putting this blockchain data onto the blockchain or making a change, and then this stuff happens. And then some of the gas gets burned, right? Like you have all this gas that's available, it gets burned, and then you might need to make a call to another smart contract, or you might need to send some ETH to someone that might burn more gas. You might need to access the memory stack. So not too critical for you to understand it, but Ethereum virtual machine uses this stack-based memory architecture. And so the way it works is the smart contract puts stuff into a memory stack and takes it off. And so every time you do that, you need to pay a little bit of gas to store whatever you're storing on the blockchain. And so I think you get the idea. You have to pay gas for any time you do anything on the blockchain. So that's kind of how it works under the hood. Again, you don't need to understand all these technical details, but it's just good to have a high level overview of that. Okay, so what is Solidity then? There's another question. Let me answer this real quick. The reason why you need Sepolia ETH, yeah, is because you need this to pay for gas, right? And so we're going to get that for you. What happens if you make a mistake with your smart contract? How would you delete it? Well, technically you can destruct a smart contract. You can make it not work anymore. But you have to remember that when you store something on the blockchain, you're storing it in a block that will live forever. So if you were to write onto the blockchain hey, what's up? I'm Kevin, and you put it into this block, and then 10 blocks go by, and you want to go back and delete that block, you cannot, because it's there. It's permanently there. You paid to put it there, and it's never going to leave. So there are ways where you can upgrade your smart contract, and you can use a proxy pattern, which is you have this one contract and then you upgrade it. But usually in the case of developing, you either do that, you do a proxy contract, or you just completely abandon that contract and you start a new one with what you want in that new contract. And then you kind of migrate your users to that new contract. There's both ways to work, but you'd have to understand that you never can really technically delete anything on the blockchain. It lasts forever. Okay, so let's look at Solidity. So what is Solidity? Well, if you know any programming language, Solidity is going to be very easy for you because it's very simple language. It's a high-level language, and you can see it's very, very much like JavaScript. If you're good at JavaScript, or if you've read or written JavaScript, it will also be very simple. Here we have an idea of a contract. So you create a contract and you wrap it like this in this kind of object. And then you can define variables just like you would any kind of other programming language. Strings, integers, booleans, all that stuff. And then you write functions. So you have a function here. So this has a string called hello world. And here we have a function that's called shout that someone can call that is publicly available. Anyone can view it, and it returns a string from memory. And we return hello. So what this would do is it would say, if someone called this function and they passed in, a read function to shout, it would say hello world, right? Very simple. This is the version of what Solidity we want to use. So Solidity needs to be compiled like most programming languages. And so the most recent version of Solidity is 0.8.27. And so what this would do is it would say, well, I want to create a Solidity contract. When you compile it, use anything greater than 0.8 and use anything less than 0.9. So it's going to find the most optimal compiler that you have available based on your configuration to compile it using this kind of in between. You can also just hard code whatever version you want there. And then this very, very top thing is the license identifier. So crypto is very much an open source thing, right? So you want to always put an identifier in you should do that for any software you write. But with Solidity, it's going to give you an error if you don't have a license. If you don't know what license to use, just use MIT. That's fine. So when you compile a smart contract, it's good to understand this. So, just like most programming languages, you need to compile your code, right? Because it's in this high level language that's easy for you as a human to write and understand. but the computer wants it in a very like more like optimized format. And so when you compile your smart contract, you compile it down into what's called bytecode. So it's bytes. It's the simplest, most compact version that the Ethereum virtual machine can read and understand. So if you were to look at it as a human, it would be very, very hard to look at, right? We could actually just go to like Base Explorer, right? And we could look at like a recent transaction, and we can see like here to get more info. This is what it looks like, right? It's not human readable, right? But this actually means something. Like we could decode this, and we could find out what it meant if we had the right parameters. And so what happens with your smart contract is you write something simple like this, it gets compiled down into bytecode. And when that compilation happens, we also generate this thing that's called an ABI. And so the ABI is good to understand because it's the interpreter, it's the way that you as a human and your front end can interpret the bytecode. So it has all of the definitions of like what variables you've defined, what functions you've defined, your contract name. Everything that's important about your contract is kind of in this like one file. It's like the map to your smart contract. And it gets automatically generated by the compiler. So you write your Solidity, it gets compiled into bytecode. You deploy that bytecode to the blockchain. And so that's what the Ethereum virtual machine wants to see is just like raw bytes. But as a human and as a front-end developer, you need an ABI to be able to read that data as it comes back off the blockchain, right? Because you need to say like, oh, well, I want to read a variable, but I don't know what kind of variable it is. Well, the ABI is going to tell you it's a string or it's an integer or whatever it is. So this is very important to understand when you compile your contract onto the blockchain and deploy it, you need that ABI. And Scaffold ETH abstracts a lot of the stuff away. So that's another good thing. And we'll show you where that happens. So now we want to like get into like Solidity a little bit more. So there's a guy, his name is Smart Contract Programmer, and he makes really good YouTube videos. And he also wrote this tool called Solidity by Example. Solidity by Example, I talked about it yesterday, has all the examples of like how to do different things. And they're really, really good. Like this is how you define variables. This is how you do constants. This is how you do an if-else statement. This is how you map information with a mapping. And so if you have a question about anything, you can come in here, and then there's a relevant video for it probably available as well on his YouTube. So you can watch the examples and kind of get a really good, concise breakdown. So I would recommend at some point you guys just take some time and do that. I see another question. Let's see. No? What if blocks run out of space because of the contract always going to stay there? Well, the block only accepts so much data. And so there's only so much that will fit into a block. So if you submit your transaction to the block and it is not going to fit, it has to go into the next one. The way the blockchain works is it only fits a certain amount. It's a lot though. I don't even know, but it's very rare that you'll not get your contract on the blockchain because it's not congested enough. You might have issues on mainnet, and the only way to like force it is to pay more gas and pay a higher fee to get it put on. Okay, so let's keep going.
I
Yeah,
just put
question.
as well OpenZClean, especially this website. Like if you want to custom like a smart contract itself, it's a great tool. It's
Yes,
just
awesome. Good
say
call out. Yeah, the Open Zeppelin. So Open Zeppelin is a company, but they're also like before they were a company, they were just like kind of a open source kind of thing where they would create these very like standard contracts that teach you or like have the best implementation from a security perspective and like standard perspective. And so if you want to create a token, well, ERC20, you can come in here and choose all the stuff you want, and it will automatically build you the code. So I want it mintable, burnable, pausable, and a callback. And it does all this for you. Super powerful. If you want to do a token, ERC721 token, like an NFT, you can change the name to the Selene token. Let's get Selene. So you get the idea, right? Like you can like customize these contracts and it will update for you and you have that mintable, burnable, pausable, and all that stuff. So yeah, this is a really good tool. I should add that actually. I'll add it later to the README. Okay, so let's talk more about Solidity. So if you're just starting with Solidity, there's like some high things you like really want to focus on when you first get started. The first thing is understanding variables. So there's three kinds of variables, right? There's local variables that you define inside of a function. Okay, so if you have a function, you can keep the variable inside of that function. They're not stored on the blockchain if they're inside that function because they're only called inside the function. They're local. But then there's outside of the function, there's the ones that get stored on the blockchain. So it's always better if you can to put your variable, if you only need it temporarily, inside of your function. But if you need something that's permanently available to like, continued state, you put it outside of the function. That's just kind of a good to know. And then there's these like concept of global variables too. Global variables are variables that you don't have to define. They're just available. So like, let's say you want to know who called your function that you wrote. It's always available as message.sender. That's the address, the public address of the user, the wallet or the externally owned account that is calling that function. If you want to know how much value they pass, like did they pass some ETH in the transaction as value, then that's available as message.value, right? So you can extrapolate that and see how much way they paid. Like maybe you want to check and make sure that they're going to pay so much money to mint an NFT, you would check message.value. You also might want to check this timestamp. Like let's say you want to create, so the way time works on an Ethereum blockchain is the time is based on the timestamp. So every time a block happens, there's a new timestamp. So if you want to restrict access to a function only X amount of seconds or minutes or days, you have to calculate it based off the block timestamp. And so that's available as well. So there's this concept of like time on the blockchain is a little weird because it's always going, but you just have to kind of look at the past to predict the future. See if there's another questions. No? Okay, cool. And then we also have different types of data types. So variables are variables, but the different types of variables are called data types. So just like any programming language, there's booleans, which can be true or false. There's unsigned integers, which can be anywhere between 0 and the maximum that's allowed to sit into the size of the variable. So the highest size is uint 256, which means it has 256 bytes. And so that would only hold a certain amount of number, but it's very, very, very large. And then there's integers, which are not unsigned, which can have a negative value. So if you want to be able to go like -1, -2, -3, it needs to be an integer. Unsigned integers are 0 and positive. So it can only be a positive number. And then there's an address as well. So an address is a 20-byte identifier. So 20 bytes, which means it has 20 characters with a 0 and an X at the front. That's why sometimes you see people have their name like 0x whatever. That is their address, and that is a 20-byte random hash. Well, it's not a random hash, but it's a hash that is created based on their wallet, their account number. Yeah, it's actually derived from the private key. Okay, so these are like the data types. Just good to know what those are. Keep asking questions if you guys have them. And we will do a little vibe coding in Solidity, yes, if we have time. Okay, so this is an example of a simple storage. So here you can see we changed the way that we do the version of Solidity. We can say, well, we want 8.26 or above. So this would make sure we had the right compiler. It's called simple storage. It has an unsigned integer that's publicly available. So variables can have a public state, or they can be private and they can only be available inside of the smart contract. And this is where you want to put like stuff that you don't want, and they're cheaper as well because they're not read. And so they're just used inside of the code. So they're usually a little cheaper to store. And you can see we have this function called set. So all we do is we have this number that we don't define as anything right away. So it has a default value. And by the way, all variables have a default value. Like booleans are always false, numbers are always zero, integers and unsigned integers are always zero, strings are always null, they're always empty, and addresses are always null as well. And so at first we don't have anything set here, but we have a a function that people can call to set that number, right? And it's public and anyone can call it. So anyone will be able to just come in here and set this number. Then we have a get function, which lets us return that number, right? You call get, it's public, you can view, and it returns an unsigned integer that's 256, which is here. If you don't define the 256, it will always assume you want to use the largest capacity of the variable size, which is 256. But it's best practice to always write it out like this. So in other words, like if we say, let's see if I can pull it up. You went 8, you went 16, you went 32, right? There's different kinds of unsigned integers, and they all have a different size. And so we look at types here. See if I can find it real quick. Yeah, here we go. So we can see here that they are different sizes, which is how much data can fit into them. So you went 8, you went 256 is the largest, you went 8 is the smallest. And so you can define this kind of range. And depending on what range it is how much data can be stored in there. So it's the highest number that would fit into that data. So there's really good documentation on the docs.solidity.lang website as well. So if you ever have a question, just come in here and search for what you're looking for. Okay, so let's keep going. We also have this concept of a constructor. So constructor is also very popular in JavaScript or other programming languages have a similar model where in the case of Solidity, anything that's inside of the constructor gets executed at the time of the contract's deployment. So if you want to set something only one time, you put it in the constructor. So it's commonly used for setting who the owner of a contract is, like if you want to do access control. It's also very much used for the name of a contract's NFT, its total supply, its symbol, things that aren't going to change that you probably just want to initialize. So you can think of a constructor as the initialization of the contract. And that's where you put anything that's hard. We'll look at it later. We also have mappings. So because one of the best use cases for Ethereum is to act as a bank, right? And to keep track of something. It's basically a database at this point, because you can have basically a set of variables and you can map them to their own state. And so it's commonly used where you might want to create a whitelist, or you might want to ban users from using your application, or you might want to keep track of a user's balance. And so you can take one variable and then map it to something else. So if you want to maintain a list of people that aren't allowed to use your application, which is not a very Web3 thing to do, but let's just say you wanted to some reason ban someone from using your contract, you would say, map all the addresses to a Boolean, and the default for all of them is always going to be false. So everyone's is going to be unbanned by default. But then you can call this function to update it from banned to true. So if I wanted to pass in Vitalik.eth as true to this mapping, then he wouldn't be able to use it if I had some kind of check in there to see is this person banned, and then don't let him call a function. It's also used for balances often, you'll have an address to an integer or an unsigned integer, which keeps track of how much value maybe they have in the smart contract. So there's all sorts of different ways where you would use a mapping to map one variable to another variable inside of Solidity. And all of these I provide Solidity by example links, so you can just quickly open them and read more and get more information. I'm kind of just glazing over this stuff because it's one of these things where you have to really go through and like take the time to read these things, and I can't cover it all in an hour. So hopefully that's helping you. And then we have functions. So just like you have functions in any kind of programming language, we already looked at them. You have this ability to do functions in a smart contract. And so if you want to, this is a good example that shows what we previously were talking about, which is mappings, right? So we have this token, a very basic example of a token, and it has a mapping that keeps track of all the addresses that call or that are in the contract inside of the mapping and their balance. So it's this thing called balances. So at the time, we have this kind of mint that we do where we set a supply. And so the concept of a token in Ethereum is you're basically creating like an asset that you can change and trade between different wallets or different accounts or addresses. And so what you do typically to create a token, what we call an ERC20 token, is you keep track of people's balances, just like a bank would keep track of how much money you deposit at the bank. But in this case, we're doing it in the smart contract. You would mint a certain supply of that token at the time that the contract gets deployed. And this is how we update the value. So we would say, well, the balances, which is here, of the person that deploys the contract should be the initial supply. So this initial supply could be, let's just say it's 10,000 tokens, right? 10,000 tokens. The minute this contract gets deployed, the person who deployed it would get 10,000 tokens. Then we have this function that lets us transfer the tokens. So how does that work? Well, it passes in who's going to receive the tokens, and it passes as how much they should be receiving. And if it passes and returns successfully, we should give a Boolean that's true or false that says that it passed. And then here we do some require statements. So that one of the other things you'll learn about Solidity is you want to often do a lot of checks in your smart contract. Because it's a smart contract that's acting as like a bank and it's holding value, you need to be very careful to make sure that people aren't doing something they shouldn't be allowed to, because the smart contract is acting as the third party intermediary. There's no real bank here, it's just code. And so you do these require statements where you say, well, if someone's going to transfer funds from their account to someone else's account and want to update the balance, we need to make sure they actually have the balance, right? So we say, well, we require that the balances of the person trying to call the function of transfer message.sender, so this is who calls the function, has greater than or equal to the amount that they want to transfer. So the person's saying, well, I want to transfer Celine, 100 of these tokens. And if I don't have enough, it's going to tell me, well, you don't actually have enough at balance, right? And then we update what the balances are. So let's say I did have enough tokens. We would say, well, the balance for the message.sender, we subtract the amount they want to send, and then we take the balances of the recipient, which would be Celine, would get added to their amount of their balances. And there we go. We have a token. So this is a very basic idea of how a token works on the Ethereum blockchain. You just have this like number. That's a token is a number, and it's either one or it's a million or a billion or whatever it is, and you're just calling this function to like transfer that value. So you can see the power of just one single small function of what you can do with a token. And all this is explained here in further detail, and there's an example in Solidity by example as well there. Any questions so far? Let's see if we got some questions. Solidity, is Solidity evolving as a language like Java did with lambdas, for example? Solidity, the people that run Solidity are a branch that came out of the Ethereum Foundation. So Ethereum Foundation used to kind of like run the Solidity compiler team. Now it's their own thing. There's another language that's called Viper, which is very similar, but it's more like Python. So both are getting popularity, I would say, recently. Evolving is a really tough word because Solidity doesn't change very often. And that's because Solidity is a very basic programming language. And the Ethereum virtual machine is a very basic kind of like processing thing. So it very rarely needs to change. Usually it's mostly security updates that get reflected into the new versions. Are we supposed to do the challenge with Solidity? Yeah, well, we're going to walk through the challenge here in like 10 minutes. Is token sort of like a ledger? Yes, it's exactly a ledger. So ledger, is like this concept of like, Celine owes me $10 and, Vitalik owes me $100. You keep track of that. Well, it's the same thing, but it's more of like a balances in this example that I did. What's the difference between Solidity and Cairo? Cairo is a zero knowledge, I believe. It's for Starknet. Yeah. So I think they do some like more advanced stuff. It's Rust-like programming language, I believe. I've written a little bit of Cairo, but it's very hard. Solidity is much simpler, and we're not going to be talking about Cairo at all.
I've been involved before into the Starknet ecosystem, so yes, Cairo is quite different, pretty hard, and yes, it's Raspberries.
Yeah, thank you. Okay, so modifiers. So we talked about variables, functions. We talked about require statements. We also have this thing called a modifier. So a modifier is kind of like a function. It actually is a function that needs to be called. So it's kind of like, I don't know if everyone's ever heard of like sub request in the concept of like HTTP. You make this kind of like sub request. You can kind of think of like a modifier as similar to a sub request where you like have to make another like call, make sure that something happens, and then come back successfully to keep going. So anytime you want to like check something like consistently across your entire application, you would create a modifier. So the most common example is only owner. Okay, so if you look up Open Zeppelin Ownable, there's a access control smart contract called Ownable, and it uses this concept of only owner, which is like, well, if you want to do something in this contract, we need to make sure you own the contract. Like, let's say you want to withdraw the money from the contract. Well, that should be you're the owner. And so you have this concept of like, well, it's kind of like a function. It has a require statement that says, if you are not the owner, then pass back an error and then revert, basically. And so if we want to do this normal contract we just created, we add this modifier to the top. Everything else is the same except for this new mint function. Like, let's say you want to create new tokens, right? Like we did this initial supply here, but now we want to mint some more. Well, only the owner should be able to like mint more tokens. Well, we have this ability to mint some tokens, and only the owner can call it. So see where the modifier is here. It's kind of like an extra thing that needs to happen in order for this function to properly execute. When a transaction fails, yeah, Vitalik is the founder of Ethereum. Sorry, I probably should specify. Like people are like, who's Vitalik? When transactions, let's say, fail, get canceled by Ethereum, are there callbacks? I mean, there's callbacks in smart contracts, and you can usually like see that data in the Explorer on why it failed or how if a callback fails. It's usually encoded, so you have to decode it. There's some really cool tools that help you do that. One of them is called Tenderly. Highly recommend checking that out. Once you get really good at like smart contracts, Tenderly will help you decode that stuff. But don't worry about that right now. We'll get to that when we get there. Modifiers can be called a filter, kind of, not really. They're called modifiers. I would more call them as like a function. They're really a function. The underscore in the modifier is just, I don't know what the underscore actually is. I think it just means like continue. So it's kind of like a return. It's like return. The Solidity have a framework. I'm not sure. There's lots of frameworks for Solidity because there's lots of like interfaces and extensions. When you talk about frameworks for deployment, maybe. Yeah. So there's Hard Hat and Foundry. Thank you, Krishna. Can non-owners trigger transactions? If it's defined that they can trigger transactions and there's not an owner pattern. So like in this contract, there's an ownership pattern, right? You have to be the owner to call mint, but you don't need to be the owner to call transfer, right? So this is how we do the differentiator. We don't pass only owner. Here's the modifier. And over here, anyone can transfer, right? You don't want to restrict only one person to transfer funds. You want anyone to be able to transfer your token. but you might want to restrict minting, right? And actually, you usually don't want people to be able to mint tokens either. It's more like for burning tokens. We have this concept of minting a token, which is like to create money. But usually in crypto, you don't allow anyone to create as much money as they want. You more allow them to burn the money. And so you might want to decrease the supply. And that's where like burning is a really cool mechanism. But anyways, we're not going to go into that too deep. Okay, we're ready. We're going to do a quick workshop. So actually, I'm not going to do this workshop. I'm just because we only have 15 minutes. I'm going to walk through the simple NFT example, but everyone should do this workshop on your own time if you can. And it walks you through very simply. And I want you guys to try to deploy this contract, which is a very basic counter contract. And so all you need to do is follow these steps. You can either get clone scaffold ETH, or you can use the npx create ETH command, and that will install scaffold ETH for you. And read over Solidity by example and play around a little bit with the examples, and then try to deploy this contract with scaffold ETH if you can. This is like your challenge for today. You don't have to do it tonight, probably. You could do it anytime this week, but I would definitely try to do it. And it's going to walk you through all the steps here. So right now I want to focus on